wormholes, time warps, alternate universes, we've all heard crazy theories about what happens inside a black hole. So what's the real story? And most importantly, what are black holes exactly? What if you fell into one? Well, if you love mysteries, you're in the right place, because in today's video, we're going to explore what's actually inside a black hole. So, are you ready to find out? But first, let's understand what a black hole actually is. Well, a black hole is basically a region in space where gravity becomes so strong that nothing can escape it, not even light. And despite the name, it's not some kind of hole you can fall through like a tunnel. It's actually an enormous amount of mass compressed into an incredibly small space, usually formed when a massive star collapses under its own gravity. There's a boundary around it called the event horizon, and it's not something you can see or touch. But once anything crosses it, there's no way out, because every possible path leads you inward. This idea comes from how escape velocity works. The stronger the gravity, the faster you need to move. If enough mass is squeezed into a small enough region, that required speed becomes greater than the speed of light. And since nothing can travel faster than light, escape becomes impossible. Now, to give you a sense of scale, if Earth were compressed down to just a few millimeters, even light wouldn't be able to get away. That's how extreme this is. Because of that, black holes can't be seen directly. The only way scientists can detect them is by observing how their gravity affects nearby stars, gas, and light around them. In short, then they're super mysterious. So, are all black holes the same? The short answer is no. While they might all be called black holes, they're not all the same. This is because astronomers divide them into 3 categories based on their mass, and that difference completely changes how they form and behave. The first one is called stellar black holes. These kinds of black holes form when a massive star, much bigger than our sun, runs out of fuel and can no longer hold itself up. Its core collapses inward, triggering a supernova, and what's left behind becomes incredibly dense. Some of these are only the size of a city, but can hold several times the sun's mass. Many of them don't stay quiet either. If they're paired with another star, they slowly pull gas from it, heating it up and producing strong X-rays that scientists can detect. The second type is supermassive black holes. These are on a completely different scale. Almost every large galaxy has one sitting at its center, including our Milky Way. The one we live around, Sagittarius A star, holds about 4 million times the mass of the Sun, and that's actually considered small compared to others. Some reach tens of billions of solar masses. What's strange is that scientists still aren't sure how these giants formed so early in the universe. What they do know is how they grow. They feed on surrounding gas, dust, stars, and even merge with other black holes when galaxies collide, slowly becoming even more massive over time. The third type sits right in between, and this is where things get interesting. These are called intermediate black holes. Based on everything we know, they should exist because over time, and smaller black holes should collide and build up into mid-sized ones. Their masses are expected to range from a few hundred to hundreds of thousands of times the sun's mass. The problem is, they've been pretty hard to confirm. Scientists have found several strong candidates, but clear proof is still limited. And beyond these 3, there's also a possible 4th kind, which is called primordial black holes. Well, unfortunately, these are purely theoretical for now, believed to have formed in the first moments after the universe began, under extreme conditions that no longer exist today. But how many black holes are there actually? Now, this might be hard to say, but according to the Space Telescope Science Institute, roughly 1 out of every 1,000 stars is massive enough to end its life as a black hole. That might not sound like much at first, but when you remember the Milky Way alone holds over 100 billion stars, the numbers get serious fast. Based on that, scientists estimate our galaxy could contain around 100 million black holes. But the tricky part is that most of them are completely invisible. They don't emit light, and unless they're pulling gas from a nearby star or colliding with another black hole, there's almost no way to spot them. That's why estimates vary so much. NASA suggests the real number could be anywhere from 10 million to as high as 1 billion stellar black holes in our galaxy alone. And the nearest known black hole in our galaxy is Gaia BH1, and it's only about 1,560 light-years away. So, in simple words, there are millions or maybe billions of them. Now, here's the real question. What's inside a black hole? Well, we know what happens outside the black hole as you approach its event horizon, the point of no return. Once you reach that boundary, the escape speed is greater than the speed of light, and since nothing with mass can move that fast, there is no path back out. That part, at least, physics handles well, but the real trouble starts after that. Inside the event horizon, things stop behaving in ways that feel normal or even visualizable. In ordinary life, you can choose to move left, right, forward, or backward. Inside a black hole, that freedom breaks. According to General Relativity, once you are inside, every possible future path leads inward. In a very real sense, the center becomes your future. Now, here is where things get truly scary. Physics can describe the outside of a black hole surprisingly well, but the inside is where the equations begin to crack. Classical relativity says all the matter that formed the black hole, plus everything that ever fell into it, keeps collapsing until it reaches a singularity. That singularity is usually described as a point of infinite density, where space-time curvature becomes infinite and the laws of physics stop making sense. But that description comes with a giant warning sign. Infinite density is not really a satisfying answer. We mean it is more like physics admitting it has hit a wall. The equations say infinity, but most physicists take that as proof that the theory has broken down there, not that nature literally works that way. So when people say the center of a black hole is an infinitely dense point, that is what classical physics predicts, but it is probably not the final truth. And it gets even stranger if the black hole is spinning. In one mathematical solution, called the Kerr solution, the singularity is not a point at all. It becomes a ring. That sounds like science fiction showing off, but it comes straight out of the equations. Even so, most physicists do not think this neat ring picture survives in a real black hole formed from an actual collapsing star. Real collapse is messy. Real matter is messy. Reality rarely behaves as cleanly as the math on a chalkboard. Some ideas go even further and suggest the singularity may not be a point or a ring, but some kind of inner surface. Others suggest singularities may not physically exist at all once quantum effects are properly included. And that is the honest answer here. We do not yet know what the inside truly looks like. But because the two great theories we rely on, general relativity and quantum mechanics, do not yet fit together properly at that depth. What makes black holes even more bizarre and brain-blowing is how little they seem to remember from the outside. You could build one from a star, from gas, from radiation, from collapsed matter, from books, planets, or the contents of an entire civilization, and once it settles down, it can still be described by only 3 numbers: mass, electric charge, and angular momentum, which is spin. That is it. No visible record of what went on. Physicists call this the no-hair theorem, which is a funny name for a brutal idea. Black holes erase almost all the detail. That leads straight into one of the biggest headaches in modern physics. If all that information falls in, where does it go? And that question became much sharper once Jacob Bekenstein and Stephen Hawking showed that black holes are not just cosmic vacuum cleaners. They have entropy, they have a temperature, and surprisingly, they are not truly black. Hawking showed that black holes should emit radiation, which we now call Hawking radiation, and over absurdly long timescales, they can slowly evaporate. That changes everything. Because if a black hole can disappear, then what happens to all the information that fell into it? Hawking's original result suggested the radiation was purely thermal, meaning it carried no detailed memory of what created the black hole. That would mean information is lost. But in ordinary quantum mechanics, information is not supposed to vanish. That clash is the famous black hole information paradox. There is one more twist. And honestly, it is one of the wildest ideas in physics. The entropy of a black hole does not scale with its volume. It scales with the area of its event horizon, not what is inside, but the surface. That hint led to the holographic principle, the idea that the information about what is in a region of space may actually be encoded on its boundary. So the inside of a black hole may not store information the way a box stores things. The event horizon itself may be doing the bookkeeping. That is why some physicists think the lost information is not truly lost at all. It may be hidden in the fine structure of Hawking radiation, encoded in ways we do not yet understand. So what is inside a black hole actually? Well, according to classical relativity, a trapped interior running toward a singularity. According to modern theoretical physics, a place where space-time, information, entropy, and quantum reality all collide. According to honest science, no one knows what's inside a black hole, but maybe someday we will find out. What do you think? Will we? How might falling into a black hole feel? Now, we have a clear idea of what a black hole is, but what would it actually feel like to fall into one? Well, first of all, you don't have to worry about anything except your life. As you get closer, gravity wouldn't pull on you evenly. The side of your body closer to the black hole would feel a stronger pull than the rest, slowly stretching you out. That's what scientists call spaghettification. If the black hole is big enough, you might actually cross the event horizon before that stretching gets extreme, and that moment wouldn't feel like crashing into anything. Like there's no surface there. What really messes with you is time. From your side, everything might feel normal. But to someone watching from far away, you'd seem to slow down as you get closer to the edge. It's similar to moving near the speed of light. Your time and theirs stop matching. In fact, even after crossing in, you could still see the outside universe. Light can fall in, so distant stars and galaxies would still be visible as you move deeper. And what happens next is a question no one knows for sure. Well, that's it from us. We hope this video has given you some valuable insight into one of the strangest and most mysterious objects in the universe. Thanks for staying with us this far, and be sure to smack that like and subscribe button. We'll see you in the next one.